So the major areas that we'll target for this particular review session is the general log properties. We're going to solve around 4 to 5 questions on basics of logs. Then we're going to take certain questions on graphs and how log functions and in their inverse are correlated. And there are certain critical properties that is important for the course. So the first, like the basic properties that we learn, of course, is like the one of the simplest of all is the conversion of a to the power x equals to b into a logarithmic relation. So x is log of b to the base a. Now here, as we also know that if this base is e, as we know e is the Euler's number, if e to the power x is b, then x is ln b. So remember that if you got log of b to the base e, it is referred as ln, so natural log, so ln of b. Now, one of the very important thing is to understand this interconversion and how I use these all the properties that I'm discussing to solve the problem. So one of the first property that we have is simple properties: log 1 to the base a or log a to the base a. This is 0. This is gonna be 1. So this is 0 always. Remember that your base must be positive, a must be positive, and a should not be 1. So that's a required condition for any log term. So if you have log x to the base y, here the required limiting condition is that your x and y both must be 0, must be greater than 0, and your y should not be 1. So this is your limiting condition. Now, coming to the log properties, the core properties that is common in SL and HL both, you got log a to the power m to the base b. This can be written as m log a to the base b. So if you have got, like, for example, log x squared to the base 3, I can write down 2 log x to the base 3. Or vice versa. So from here to here, as well as from here to here, you should be both comfortable doing it. Now, if you look at a simple example, like for example, let's say if you got 2 log x plus 3 log y minus 7. So if I wanted to write down this as a single log property, a single log, so you're going to throw this first thing up on the power. This becomes log x squared plus log y to the power 3. And now, since here the base by default is 10, if you have just simply log, the by default base is 10. So this 7 can be written as 7 log 10, because log 10 we know is 1. So this becomes basically nothing but log x squared y cubed over 10 to the power 7 with the 2 properties that I'm going to write next. So if you got log xy to the base a, it is log x to the base a plus log y to the base a. So it's like from here to here you can go, and from here to here you can go. If you got log x upon y to the base a, this can be written as log x to the base a minus log y to the base a. So this is what I applied. So I club these two together. So if you're adding up, so log a plus log b can be written as log ab, provided the bases are the same. So I did that. And here is minus. So log a minus log b can be written as log a by b. So that's how you got this particular term. So one of the another very important property that a lot of students lose marks is for if you got an exponent, let's say a to the power log x to the base a. So if you're raising an exponent to the same log base, the answer is straight away x. So for example, if you got 3 to the power of log x to the base 3, the answer is x. If you got 5 to the power of log, let's say 3x to the base 5. So this, firstly, I'm going to bring this 3 up. So it becomes 5 log x cubed to the base 5. So the answer is x cubed. Now, let's just take some problems on the basics of logs, like how do we apply those log concepts. So now one of the important property that we have is change of base rule. Indeed, this one of the question concept around which your questions mostly are based on. So if you got log a to the base b, I can write down this as 1 over log b to the base a. This is your first property. An actual change of base rule is if you got log a to the base b, I can write down this as log a to the base c over log b to the base c. So this is my change of base rule property. Now, for example, if I have got log 3 to the base 5, it is same as saying it is log 3 to the base 4 upon log 5 to the base 4. So I can put any base apart from 1, of course, and greater than 0. That can still work as this value. So for example, if I've got log of x squared to the base 8, and I want to change this base to 2. So I can write down this as log of x squared to the base 2 over log 8 to the base 2. So you can further bring this down. So it'll become 2 log x to the base 2 upon, and log 8 to the base 2 is, we know that it is 3. It's because log 8 can be written as 2 cubed, and this 3 comes down. So this, the answer can be, you can see that the base 8, now we got in terms of base 2. So change of base rule, one of the very important outcome is this one. That comes handy, and there are questions assessed in the DP exam about this. I'll take one example. Now, for example, the question is 5 log x to the base 5 equals to 1 upon log, or let's say here equals to, this is equals to log 5 to the base x. So the moment you see that the log and the base is flipped, they are reciprocal of each other. So log of x to the base 5 is 1 upon log x to the base 5 to the base x. So this is the property. So either you can change this into this form or this into this. So I prefer to do that here. So 5 log x to the base 5 can be written as 1 upon log of x to the base 5. So you can now take, let us say, log x to the base 5. You take it as, let's say, a. So it's 5a equals to 1 over a. So a squared is 1 over 5. So a is plus or minus root 5. And so you get log x to the base 5 as 1 over root 5, which gives x is 5 to the power 1 upon root 5, or x is 5 to the power minus 1 upon root 5. So these are the two solutions of this equation using change of base rule. Now, there are some questions which are further straightforward. Let's say if you got log x to the, I'm going to take a proper question from exam bank. So here is the question. Let's say log x to the base 2 minus log y to the base 4 equals to 4. And log x minus 2y to the base 2 is 5. And if I wanted to solve this question, let's say I'm first concern is that here the base is 2 and here the base is 4. So remember to change the base. Like firstly here, I'm going to make the base to this common base. So I change the base of the second one to 2. So this I can change it like this. And so you got here, and you get log x to the base 2 minus log 4 to the base 2 is 2. So it becomes log y to the base 2 upon 2 equals to 4. If I multiply out everything by 2, so you'll get 2 here, this get cancelled, and you get 8. So you'll get, if you write down this as a single fraction, you get log x squared to the base 2, because you can push this back in power, upon y equals to 8. So what we get is x squared upon y is 2 to the power 8. So from here, we get a relation between x and y. So y is x squared upon 2 to the power 8. So this is your first equation. And second equation you'll get is x minus 2y. If you get rid of log straight away here, this becomes 2 to the power 5. So now we're going to solve these two equations. So either you can replace y is x squared upon 2 to the power 8 um, and put out here, or you can make x the subject and you put the y value here. So I would recommend that you make y the subject. You already have it here. Put it out here. So you get x minus 2 upon 2 times x squared upon 2 to the power 8 equals to 2 to the power 5, which is 32. If you simplify this, this becomes 2 to the power 7. And so you can solve this like a quadratic. So this is x here. So if you solve this, you'll get a proper value for x and a proper value for y.